Today, we will be discussing HTTP, the protocol that enables web browsers and servers to communicate and transfer information over the internet. We are going to talk about HTTP, which stands for Hypertext Transfer Protocol. HTTP is a foundational networking protocol that runs over TCP or IP. The protocol suite responsible for how data packets are transferred over the internet. HTTP is what enables communication between web browsers like the one you are using now and web servers which host the websites you visit. To understand HTTP, it's useful to know a bit about TCP or IP, even though web developers don't need to dive deep into it. TCP or IP is crucial for moving data across the internet from one machine to another, ensuring the data packets arrive at their destination correctly. While the intricacies of TCP or IP can be complex, what's important for us is how HTTP uses this protocol to transfer data efficiently. Let's talk about the different versions of HTTP. For most of the web's history, HTTP slash 1.1 has been the standard. It has served us well, but has some limitations, especially in terms of speed. More recently, HTTP/2 has been adopted by many websites to address the speed concern. HTTP/2 maintains the core concepts of HTTP/1.1 but enhances the speed of communication between browsers and servers, making web page load faster. Looking ahead, HTTP/3 is currently in development and promises even faster communication by using a different underlying protocol called UDP instead of TCP. But for now, we will focus on the basic HTTP workings that are common across all these versions. When you access a website, the process starts with a DNS lookup. The web browser extracts the domain name from the URL, such as w3c.org. In this link, https://www.w3c.org slash and sends it to a DNS server to get the corresponding IP address. For instance, w3c.org resolves to the IP address 193.51.280.66. The browser then uses this IP address to establish a TCP connection with the web browser. Once the connection is established, HTTP functions as a request response protocol. This means that the web browser sends an HTTP request to the web server. Typically, this request asks for a web resource like an HTML file, image, CSS style sheet, JavaScript file, or video. In response to this request, the web server sends back an HTTP response. This response usually contains the requested resource or other information, completing the cycle of communication. Whether it's an HTTP request sent from a web browser to a web server or an HTTP response set back from the server to the browser. Both follow a similar structure consisting of four key parts. First, let's talk about the start line. The start line differs slightly between requests and responses. In an HTTP request, the start line includes the HTTP version being used, the types of requests such as GT, POST, etc., and the path to the resource. For example, in the request for the Wikipedia page on the World Wide Web, the start line is get/wiki/World Wide Web http://1.1. This indicates that it's a GET request for a specific path using HTTP version 1.1. For HTTP responses, that start line includes the HTTP version, a status code, and a status phrase. For example, is HTTP slash 1.1 OK, which indicates that the request was successful. The second part is header field. Header fields provide additional information about the request or response. They are written as key value pairs with a keyword followed by a colon and a value. For instance, our HTTP request example, we have headers like host colon en.wikipedia.org specifying the host being requested and user agent Mozilla slash 5.0 Chrome slash 48.0 which tells us the server what type of browser is making the request. In the HTTP response, you might see headers like content length, 56, 57, 9, which indicates the size of the response body, and content type, for example, text slash HTML, which tells the browser the type of the content being sent. After the headers, there is a black line. There's a blank line. The blank line is crucial as it separates the header fields from the message body. The final part is the optional message body. This part of the message contains the actual data being transferred between the web browser and web server. In an HTTP request, the message body might be empty or it could contain data such as from inputs from a user. In an HTTP response, the message body typically contains the web resource request like an HTML page. In our Wikipedia example, the response message body would contain the HTML content of the World Wide Web article. So to summarize, an HTTP request and response both consist of a start line, header fields, a blank line, and an optional message body. Understanding these components is essential for anyone working with web technologies as they are the backbone of how web browsers and servers communicate. Now, first, let's look at HTTP request methods. These methods define the type of action a client wants to perform on a resource. The most common request method is GET, which is used when a web browser requests a web page or resource from a server. A GET request asks the server to send back a representation of the specified resource. Another important method is POST, which is used when submitting data to a server, such as when filing out and submitting a web form. Post requests create new resources on the server with the data provided in the message body. Other methods include head, similar to get, but it only requests the header and not the body of the resource. Patch, used to apply partial modifications to a resource. Put replaces an existing resource entirely with the data provided in the request. Delete, as the name suggests, this method deletes a specified resource. Understanding these methods is crucial for web development, especially when working with APIs and creating dynamic web applications. Now let's talk about HTTP responses about status code. These are three-digit numbers that indicate the outcome of a request. The most common status code is 200 or OK, which indicates that the request was successful and the server is returning the requested resource. There are other important status codes as well. For example, 301 moved permanently and 302 found. These codes indicate that the resource has been moved to a different URL. The browser will automatically redirect to the new URL. Moving on to 304, not modified. This code tells us the browser that the resource has not changed since the last request, allowing the browser to use the cached version. 403 forbidden. This indicates that the server understood the request, but the client does not have permission to access the resource. Now, 404 not found, one of the most well known codes that indicates that the requested resource could not be found on the server. And finally, the 500 internal server error. This code is returned when something unexpected happens on the server and it cannot process the request. Now, URL shortening, a technique used to create URL shorter and more manageable that redirect to longer original URLs. This technique is especially useful in situations where space is limited or when you want to make a long and very complex URL easier to share. So, what exactly is URL shortening? It's a way to take a long URL and turn it into a much shorter version. For example, a long URL for um, like this, um, sorry, a long URL like this um, can be shortened into something simpler like this tiny URL example that at last says URL wiki. These shorter URLs are particularly helpful on social media platforms like Twitter, where there's a character limit for posts. By using a short URL, we can save much space and you can make your message more concise. There are several popular services that provide URL shortening, including bit.ly, rebrandly.com, and tinyurl.com. These services take your long URL and create a short link that redirects to the original URL. Now let's take a look on how URL shortening works. When a user types or clicks on a short URL, the URL shortening service responds with an HTTP response. This response includes a 301 status code, which indicates a permanent redirect. It also includes location header that specifies the original full URL to which the short URL redirects. Let's consider an example when a user access tiny URL shortened link. The service sends an HTTP request to the tinyurl.com server. The request might look something like get slash URL wiki HTTP slash 1.1 with the host header set to tinyurl.com and the user agent header indicating the browser being used. In response, the server sends back an HTTP response with a 301 moved permanently status code. It includes a date header showing when the request was processed and importantly, a location header pointing to the full URL colon http colon slash slash en dot wikipedia.org slash wiki slash URL. I mean the long link that was shortened. This tells the browser to redirect to the specified Wikipedia page. In summary, URL shortening is a practical way to manage and share URLs more efficiently, and it relies on HTTP status code and headers to redirect users to the original longer URLs. Now, what is browser caching? Browser caching is basically storing web content locally to speed up future accesses. The main benefit of browser caching are faster page loads and reduced network traffic. So, when you revisit a site instead of downloading everything again, the browser can load much of the content from the cache. This not only makes the page load faster but also reduces the amount of data that needs to be transferred over the internet, lightening the load on the servers. Now let's see how it works. So when you visit a web page for the first time, the browser saves some of the content like images, scripts, or to its cache. The next time when you visit the same page, the browser can pull these contents directly from the cache, making the page load faster. To ensure that users see the most up-to-date content, browser use something called e-tags. An e-tag is an unique identifier for a version of a web resource. When a browser requests a cache resource, it sends the e-tag with the request. The server then checks if the resource has changed. If it hasn't, the server responds with a 304 not modified status, telling the browser that it's okay to use the cached version. If the content has changed, the server responds with a 200 OK status and sends the updated content along with the new e tag. In summary, browsers caching is all about improving user experience by speeding up access to websites and reducing the load on web servers. E-tag plays a vital role in making sure that cached content is always current. Now, here let's talk about the HTTP traffic. HTTP, which stands for Hypertext Transfer Protocol, is used to transfer data between a web browser and a web server. However, one significant issues with HTTP is that all the traffic can be viewed by third parties. This is where a network sniffer comes into play. A network sniffer is a type of software that monitors and inspects network traffic. Using a network sniffer, one could potentially intercept and view sensitive information, for example, password, credit card numbers, and other personal data, and being transmitted over the network. This poses a significant security risk, especially for websites that handle sensitive transactions. To address these security concerns, we have HTTPS, which stands for Hypertext Transfer Protocol Secure. HTTPS encrypts the HTTP traffic between a web browser and a web server, making it much harder for third parties to intercept or tamper with the data. This encryption is crucial for protecting sensitive information, ensuring the personal and financial data remains secure during transmission. HTTPS relies on a protocol called Transport Layer Security or TLS to secure the data. TLS uses asymmetric public keys to encrypt the communication between the browser and the server. For a website to use HTTPS, it must have a digital certificate. The certificate is issued by a trusted certificate authority or CA and contains the public key used by TLS for encryption. The certificate verifies the website's identity, ensuring users that the site is legitimate and that their data will be securely transmitted. When you see the padlock icon next to a URL in your browser's address bar, it indicates that the website is using HTTPS and your connection is secure. So, to summarize, while HTTP allows data to be easily interpreted, HTTP provides a secure way to transmit information over the internet, protecting against um, eavesdropping and data breaches. This means HTTPS essential for any website that handles sensitive information. So that's all for today's lecture and hope to see you in the next one.